Hi, welcome to part 3 of Troubleshooting SQL Server IO. Let's do a quick recap. In part 1, I talked about a DMV, sysdm virtual file stats, and using that DMV, you can track latency and the physical and the logical reads and writes, and you can do a lot of mathematics around it. That DMV is very, very critical whenever you are troubleshooting SQL Server IO performance. In part 2, I demonstrated the usage of performance monitor counter, average disk second per read, and I showed a couple of other counters, but this one is also very critical. Both these videos, part 1 and part 2, are available in the YouTube channel. Today, in this video, part 3, I am going to show you how you can use another bunch of DMVs, dynamic management views, to track most expensive IO queries. When I say most expensive IO queries, I mean workloads and queries that are causing maximum IO, read or write. So let's get started with the demo, and as usual, no slides. I'll switch over to the VM, and I can't see where is my VM. Here, there it is. Okay, so a lot of scripts are already open, and I will just go back and run that same workload that I have been running a couple of times. Where is it? There it is. Okay, took me a bit of while. So I will run memory pressure.cmd. Don't get misled. The name says memory pressure, but it's causing a lot of IO, these three workloads, and I would let them run for some time, maybe just a few seconds, and while they are running, I will show you this DMV. So I'm actually using two DMVs here, sysdm exec query stats, and this DMV has a lot of statistics about query execution, and as you can guess, it has statistics about IO also, both read and write. And I'm using another DMV here, dim exec SQL text, because I want to extract the query hash and the query text like exactly this way. So let's go and stop the workloads. Let me go and close all the windows, back to SQL, and let's run this query. And using these two DMVs, and of course we are joining them, and we're doing some mathematics around it, and when I execute this, I get this output. Now in this output, you can see, of course, there are a bunch of workloads that it shows up, but the first 2 or 3 workloads really stand out. So you can see the first one, which is select TBL orders, something, and you look at the total physical reads is way high than some of the other ones. Likewise, the second one has a very high physical read value out there, and this one. Now, the first one and the second one, they look pretty similar, but they are actually different. So and you can see they have different query hash also. So let me just pull out these two and copy this, and in a new window, just show it to you. This is probably my first one, and let's take this one. And this is my second one. Okay, so no, I took both the ones. Sorry, I took in the first copy itself, I took both. So these are my two workloads. So if you see, the first one does not have any filter, so it's actually selecting all the data from these tables, and it's just doing an inner join there. And this one has a filter on order ID. Now, of course, these two workloads are different, and that's why the signatures are different, and you get a different query hash. Now you can see that these two workloads are they come up in top most expensive IO workloads, which means they're causing maximum IO, and I have shown you the physical read number there. You can actually see more metrics, both logical, physical reads and writes, etc., to track these workloads. But remember, this is I was focusing on read. In fact, in all my videos, I focused on read workloads, not really much on write workloads, and that's why I was trying to get only physical reads. Now, just looking at these queries and the workloads would not really help. The next thing you want to do is pull out the execution plan and try to figure out where exactly IO is being caused. So what you can do is in this workload, as I can see, you have the query hash here. You can take this query hash and copy it and replace this query hash here. And what am I doing? Basically, I'm trying to extract the query plan from this DMV, dim exec query plan. And of course, again, I am doing a cross supply, which is another way of joining with my query statistics. So I'm supplying the query hash from my stats to this query plan DMV. This is actually not a DMV, just to be more technically correct. This is a DMF, dynamic management function, which always takes the plan handle from the query stats, and I'm filtering on this particular query. When I execute this, I will get the plan, and you can see there are multiple plans out there. And if I click on, let's say, the first one, and let me zoom a bit, can I? Okay, let's not. So I'll use the zoom tool here and zoom a bit. And when I zoom into this query, it's pretty evident on the face of it. It's probably one of the most simplest plans you would ever see. There is the problem, table scan, and you can see I do not really have any index on it. This is the most expensive iterator that I have right now. But let me tell you, this is one of the hash that this is one of the queries that you've seen which does not really have a filter. So I am not trying to tell you that if you create an index, this is going to run faster. It might just help that if you land up creating a non-clustered index, which is a covering index maybe, so the number of reads are going to be lesser. But because it has no filter, whether you have a scan, table scan, which means it is a heap, or whether you have a clustered index scan, or whether you have a non-clustered index scan, it's all going to be a scan. Because there is no filter, you're going to touch every page and you have to read every bit of data. So creating an index here may or may not be really helpful, but all that I'm trying to show you is how you are going and identifying your expensive query by IO, and you are trying to figure out what is causing it. Now, the moment I took this example of index, you can clearly see that SQL Server is indeed suggesting you to create a non-clustered index, and it includes all the column there, and it always recommends you to create a covering index. Well, indexes, missing indexes, and the right indexes and the wrong indexes are not really part of this video. It's out of context. So I'll close this and let me take up the second one. So I'll just run this again and pull out this second one. I just copied that and I'm going to paste it here and execute this again. And then I get this one plan out there, and when I click on this, now this is a very different plan, because now I have a predicate, I have a filter here, and you can see all sorts of joins and parallelism also happening here. And you can see this time this plan in comparison is, of course, this particular iterator table scan is much more expensive. 96% of the cost only goes into scanning the table. Now if you look at what is SQL Server recommending here, it's recommending you to create index, non-clustered index on order ID, because there was a filter on order ID. Now I think this is where index will be really very helpful. But besides what the remedy is, the first step is identifying which queries are suffering from heavy usage of IO. So your first thing is you use your DMVs or perf mount counters to identify the bottlenecks, the workloads and the queries that are causing maximum IO. You investigate the database, you investigate the data file, you drill down to the worker level, which is the query, the process level, maybe the stored procedure, etc., and pull out their execution plans and really seeking, scanning where the most expense is happening. And in most cases we see that lack of right indexes or the lack of indexes altogether causes so much IO. So just to summarize, in this video I have shown you the usage of a couple of these DMVs to track queries and workloads that are causing maximum IO. Well, that's it for today and in this video. Thank you very much for your time. I hope you learned something new. Do connect with me on Twitter, @a_Bansal, and I will soon see you in my next video. Goodbye and have a good day.